So welcome back. So on this part of the lecture, we're just gonna go straight back into 1412. So the first part was just a review from 1411. We review how to keep track of the oxidation numbers. So now let's go to new material. And we're gonna start by balancing oxidation, reductions, equations, but we're gonna be doing this on a acid environment or a basic environment. So let's do the first one under acidic conditions. So the first thing we're gonna do is apply what we just learned. We're gonna assign oxidation numbers. So chlorine is by itself, so that's gonna be 0. Iodide is an ion, so the oxidation number is the same as the charge. And then on the products, we have chlorides, and we know that oxygen is always -2. There's 3 of them for a total of -6, but the overall charge is -1, so the iodine has to be +5. So from here, we can see that the chlorine is becoming chloride, and the iodide is becoming iodate. And now all we have to do is balance each one of those. So the chlorine, we're gonna balance first the atoms, 2 of them, and now we're gonna balance the charge. On the right side, all together is 2 negative. On the left side is 0, so we're gonna need to add 2 electrons. So this first reaction is our reduction, because the electrons are being added. They're part of the reactants. And we balance the chlorines, 2 of them, and the charges on both sides are -2. So we're done with the reduction reaction. So this one has to be the oxidation then. So if the other one was the reduction, this one had to be the oxidation. And how are we gonna balance this? This one is a little bit strange because as you notice, on the right side, there is oxygen, but there's no oxygen on the left side. So how are we gonna fix that? We're gonna fix that by adding oxygens using water molecules. So we're gonna be adding, so we're gonna do it down here. To the iodide, we're gonna add 3 water molecules. So that gives me the 3 oxygens that I need. So 1 iodide, 3 oxygens on the right, and 3 oxygens on the left. However, because I added water, now I have 6 hydrogens. And I'm gonna fix that by adding 6 protons. And that's why these are acidic conditions. So let's make sure that we have this right. We have 6 oxygen, 6 hydrogen, 6 hydrogens, 3 oxygens, 3 oxygens, and 1 iodide, 1 iodide. So matter-wise, the number of atoms is balanced. Now we have to make sure that the charge on both sides is the same. On the right side, we have a total charge of -1. Or actually, that's how we write oxidation numbers. We have a total charge of 1. 1 negative, sorry. 1 negative. On the right side, we have a total charge of 5 plus, because we have 6 plus, and 1 negative. So 5 plus is on the other side. So how are we gonna make that match? What we're gonna do, we're gonna add 6 electrons on the right side. That way, we will have 5 plus from the original stuff plus 6 electrons altogether is 1 minus. So now we can see that the charge is balanced on both sides. However, just like you learned on Chem 1411, the amount of electrons on the reduction has to be the same as the amount of electrons on the oxidation. And that's not the case right now. We have 2 electrons on the reduction and 6 electrons on the oxidation. So we're gonna fix that by multiplying the whole reduction reaction times 3. That will give me 6 electrons plus 3 chlorides producing 3 chlorines producing 6 chlorides, 2 times 3. And that way we have 6 electrons on the left, 6 chlorines on the left, and 6 chlorides on the right, with a total charge of 6 negative on both sides. And now we're gonna bring these two reactions together so we can get the balance equation. So the reason the electrons have to be the same is because the electrons do not show on the final equation, so they have to cancel because you have it on the left side and on the right side. And then we put everything together. So 3 waters plus 1 iodide plus 3 chlorines producing 1 iodate plus 6 chlorides plus 6 protons. So let's double check. 6 hydrogens on the left side, 6 hydrogens on the right side. Three oxygens on the left side, 3 oxygens on the right side, 1 iodide, 1 iodide, 6 chlorines, and 6 chlorine. So matter-wise is balanced. Now let's double check the charge on both sides. The charge on this side is still just -1. The charge on this side, 6 negatives cancel 6 positives, so it's just -1. So this is a reaction that is properly balanced on an acidic environment. Important things here is that we realize that there's a total of 6 electrons involved in this process. So the number of electrons for this particular reaction is going to be 6 electrons, which we're going to use later on the chapter. So let's do this again so you can see the whole process once more. And I know you can rewind it and listen to everything again, but just in case I say something different, that it's better for you. So first thing we do, step number 1, we're going to assign oxidation numbers so we can identify the reduction and the oxidation. So chlorine is by itself, so 0. Iodide is an ion, so -1. Chloride is an ion, -1. Iodate We know that oxygen is -2. There's three of them, so altogether -6. But the overall charge of the polyatomic ion is -1. So iodide is going to have to be +5. So we can see that the chlorine is going from 0 to -1. So that's going to be our reduction. So chlorine plus electrons is going to be chloride. Before we find out how many electrons we need, we're going to balance the atoms. So that way the right side is going to be 2 negative. So that means I'm going to need 2 electrons there. And that reaction is balanced. This is my half reaction for the reduction. And we know it's reduction because the electrons are part of the reactants. Reduction, reactants. So the electrons are part of the reactants on the reduction. What about the other part? On the other part, I have the iodide becoming iodate. So we're going to balance the iodide first. It's already balanced, 1 and 1. And there's 3 oxygens on the right side and no oxygens on the left side. So we're going to fix that by adding 3 water molecules. So we add oxygens by adding 3 water molecules. However, since we're adding water, we're adding the 3 oxygens, but we also add 6 hydrogens. So we're going to fix that by adding 6 protons on the right side. So we got 6 protons on the 6 hydrogens on the left side, 6 hydrogens on the right side, 3 oxygens on the left side, 3 oxygens on the right side, and 1 iodide. But like the same thing we did on the first one, we have to make sure that the charge on the right side equals the charge on the left side equals the charge on the right side. On the left side, the charge is altogether 1 minus. On the right side, the charge is altogether 5 plus, because we have 6 plus 1 negative. However, we know that -1 is not equal to 5 plus. So the only way to fix that is by doing 6 minus over here, which gives us 1 minus, and 1 minus equals 1 minus. So that means we're going to be adding 6 electrons on the right side. And if you notice, those electrons are part of the products. So whenever you have the electrons on the product side, that means that electrons are being produced or electrons are being lost by the reactant. So this is the oxidation process. So now we're going to bring the equation back together into only one equation, because that was the half reaction for the oxidation, oxidation. So when we bring it together, the amount of electrons on the oxidation and the reduction has to be the same. So far, we have 6 on the oxidation and only 2 on the reduction. So we're going to have to multiply that 2 by 3 to make it 6. But we cannot just multiply the electrons. We have to multiply the whole reaction. So when I do that, I'm going to get 3 chlorines plus 6 electrons, producing 6 chloride. And then I'm going to combine that with my other reaction, which was 3 waters and 1 iodide, producing iodate plus 6 proton plus 6 electrons. I'm going to combine both of them. Whatever repeats on the left side and the right side cancels, and everything else comes down. And if you notice, we are finishing up with this reaction here. Which is a reaction on an acidic environment. So that's how we do balancing in acidic conditions. And now you get to practice. Once you practice that, and make sure you get to the textbook and practice some more, now we're gonna do it in basic conditions, which is exactly the same that we just do, but we do one more step at the end. So let's do this. So the iodide is gonna turn into iodine, and the permanganate is going to turn into manganese, Roman numeral 4, oxide. So the first one, really easy to balance. We need 2 iodides on this side. That means the left side is a total of 2 negatives, so we're gonna need 2 negatives, and we do that with electrons on the other side. And that one is already balanced, and this one, the electrons are part of the products, so this one is oxidation. So that means the one with the permanganate better be the reduction. So we better find the electrons on the left side with the reduction with the reaction with the reactants. So on this one, we have 1 manganese, 4 oxygens, and 2 oxygens. So we're gonna fix that by adding 2 water molecules. So right now I got 1 manganese on the left, 1 manganese on the right, 4 oxygens on the left, and a total of 4 oxygens on the right. However, I just added 4 hydrogens, so I'm gonna have to put 4 protons on the left side. And now I need to balance the charge. So this whole left left side, actually no, we're not gonna do that yet. So we still need to balance for a basic. So right now, short of the electrons, we already balance for everything else. So, but since we're doing basic, we have to do one more step before we do the electrons. And the step is gonna be that these have to be basic. So you gotta get rid of the protons. So we're gonna do that by adding 4 hydroxides, but we have to add it on both sides. And then we're gonna combine everything that we can make water to make water. So 4 hydroxides and 4 protons give me 4 water molecules plus permanganate producing manganese 4 oxide plus 2 water molecules plus 4 hydroxide. However, I have water on both sides. So these 2 waters get canceled by 2 of these waters. So my final equation is going to be 2 waters plus manganese, plus permanganate produce manganese 4 oxide plus 4 hydroxide. As you notice, there's no evidence of acidity. All we have is a basic environment because we have hydroxide. And now we're ready to balance the charges. So this whole side is 1 minus, while this whole side is 4 minus. So that means we're going to have to add 3 electrons on this side. That way we have 4 minus on both sides. So we're going to add 3 electrons, which is going to make it reduction the way it was supposed to be. And at this point, we are ready now to add everything back together. So we're going to get rid of the reaction that we are not using anymore. So the reaction that we are dealing with are going to be 2 iodides producing iodine plus 2 electrons and the one we just did. But as you notice, we have 2 electrons on the oxidation and 3 electrons on the reduction. So how are we going to fix that? We're going to multiply on the first one everything times 3, so we get 6 electrons. And on the second one, we're going to multiply everything times 2, so we get 6 electrons. So we're going to get, on the bottom one, we're going to get 6 electrons plus 4 waters plus 2 permanganates, producing 2 manganese 4 oxide plus 8 hydroxides. So let's double check. We got 6 electrons on the left side, 8 hydrogens on the left side, 8 hydrogens on the right side, 4 oxygen, 8 oxygen, 12 oxygens on the left side, 12 oxygens on the right side, 2 manganese and 2 manganese. And the total charge on the left side is going to be minus 7, 6 electrons plus, minus 8 actually, plus 2 more, 8 electrons. And on the right side, you're going to have 8 negative. On the right side, you're going to have 8 negative. So this half reaction is properly balanced. And then the other one, we said that we were going to multiply by 3. So we're going to get 6 iodides producing 3 iodines plus 6 electrons. So 6 iodine on the left side, 6 iodine on the right side, negative 6 on the left side, negative 6 on the right side. And now we're going to combine all together. The electrons are going to cancel. So we're going to end up with 6 iodides plus 4 waters plus 2 permanganates, producing 3 iodines plus 2 manganese 4 oxide plus 8 hydroxides. So we transfer everything. So this is our balance equation. Let's double check. 6 iodide, 6 iodide, 8 hydrogens, 8 hydrogens, 4 oxygen plus 8 oxygen equals 12 oxygens, 4 oxygen plus 8 oxygens equals 12 oxygens, and 2 manganese and 2 manganese. So all the atoms are balanced. We clear the screen a little bit. And let's make sure that the charges are balanced also. The whole right side is going to be 6 negative plus 2 negative, which is 8. The whole right side is going to be just 8 negative. So it's balanced charge-wise. So that's my balance equation on a basic environment. So remember, all we did exactly the same thing we did with the first one, acidic, but then for every proton that we added a hydroxide, but we put it on both sides. Then we combined the hydroxide with the protons, and we made that into water. And if we had water on both sides, we cancel as many as we can, and then we did the balance, the charge balance. So for this one, you can go back and watch the recording because most of it is what we already covered 3 times, which is the acidic conditions, and then you make it into basic. So once you do that, you're ready to do this one on basic conditions. And with that said, that's how we balance redox reactions in acidic environment and basic environments. When we come back, we're going to start working on constructing galvanic cells, which are basically your batteries that you use every day, and talk about electrolytic cells, which are the opposite of producing energy. And we're going to see all the different terms that we're going to need to learn to be able to communicate this knowledge. So until the next time, I will see you soon.